Hello, you are welcome to this tutorial. In this tutorial, we shall be looking at the configuration of network address translation, NAT, and we shall be focusing on Dynamic Nat. My name is Claude Fozao, and I'll be taking you through this tutorial. In Dynamic Nat, we have a pool of public IP addresses, and we have private IP addresses. If traffic leaves an internal network with source IP addresses, before the traffic goes over internet, the source IP address must be replaced with a public IP address before the traffic is sent to the internet. In computer networking, there are two categories of IP version 4 addresses. There are private IP addresses and there are public IP addresses. Private IP addresses can only be used to communicate within a private network, that is within an internal network of a company. For communication that has to go over internet, hosts must use public IP addresses. So it therefore means that if PC1, for example, that is connected to an internal network, wants to send information to server 1 that is connected to the internet, communication between PC1 and the server must use public IP addresses. In the diagram, we have an internal network, and this internal network has three subnets. The first subnet is the subnet where the laptop L1 is connected to, and it has a network address of 172.16.11.0/24. There's another subnet where PC1 and PC2 are connected to, and the subnet has a network address of 172.16.10.0/24. There is another subnet between router R1 and R2 with a network address of 172.16.1.0/30. Our goal here is to configure the network in such a way that traffic leaving any of these subnet to internet, before it crosses over router R2, router R2 will replace the source IP address of the traffic with a public IP address that will be taken from the pool of addresses before sending the traffic to internet. We are going to first of all start the configuration by testing communication between PC1 that is connected to the internal network and has a private IP address with server 1 and see if the traffic will go through or if the communication will go through. So let me connect to PC1 and I verify the IP address of PC1. Right now I'm in PC1. I'm in the command prompt of PC1. I'll use the command ipconfig to display the IP address of PC1. The IP address is 172.16.10.1. I'm going to display the IP address of the server 1. So I'm on server 1. I will say ipconfig. It tells me the IP address is 209.165.201.5. So let's test communication from PC1 to the server. So I will say ping. Let me copy the IP address of PC1. I say copy IP address of server 1. So I say ping from PC1. I say ping. I say paste. Okay, let's ping the IP address of server 1 from PC1 and see if it will go through. As you can see, communication doesn't go through because PC1 is trying to send traffic to internet using a private IP address. At the end of the exercise, we are going to repeat the same test again. So we are going to do the configuration on router R2, and before we do the configuration, let's read the instructions that are given. Okay, the instruction says packet tracer configuring Dynamic Nat. Objectives: part 1, configure Dynamic Nat. Part 2, verify NAT implementation. Part 1, configure dynamic NAT. Step 1, configure traffic that will be permitted. On R2, configured one statement for ACL1 to permit any address belonging to 172.16.0.0/16 network. You should know that 172.16.0.0/16 network is a supernet of these three subnets. So if I configured an access control list to identify that supernet address, I'm using it to identify all these subnets. So I go to R2. Right now I'm in R2, so I'll use the command enable to go to privilege XL mode. In privilege XL mode, I will start by displaying interface configuration on R2 using the command show IP interface brief. As you can see, router R2 has two interfaces with IP addresses configured. There is interface serial 0/0/0 with IP address 209.165.76.139. This is the interface on R2 that is connected to the internet. Now there is interface serial 0/0/1 with IP address 172.16.1.1. This is the interface that is connected to the inside network. Let's go back to the diagram again. We can see R2 is both connected to the internet and also connected to the inside network. I go back to R2. Now on R2, I will start the configuration by going to global configuration mode. So I will use the command configure terminal to go to global configuration mode. In this mode, I will configure an access control list to identify the private IP addresses that are to be translated. So I will use a standard access control list. I say IP access list. I say standard. I can name it ACL1. Okay. It takes me to standard access control list configuration mode. In this mode, I use the command permit. Then I specify the network address 172.16.0.0. The wildcard max is 0.0.255.255. I am done configuring the access control list. The next step will be to tell the router which of the two interfaces is not outside interface, meaning the interface that is connected to the public network or to the internet. And we are going to tell the router which interface is connected to the inside network or the not inside interface. In our case, interface serial 0/0/0, that is this interface, will be configured as IP NAT outside because it is the interface connecting to the internet. So in order to do that, in order to configure that interface as IP NAT outside, I will get into the interface configuration mode using the command interface serial 0/0/0. Okay, I say IP NAT outside. That is done. I will configure the other interface as NAT inside interface to tell the router that the interface is connected to the private network. So I say interface serial 0/0/1. I say IP NAT inside. I'm done configuring the interfaces. The next step will be to configure a pool of public IP addresses to be used for the NAT. Let's go to the instructions and see the addresses to be configured for the IP address pool. So I go to the instructions again. It says step 2, configure a pool of addresses for NAT. Configure R2 with NAT pool that uses all four addresses in 209.165.76.196/30 address space. So let me just copy it to make things easier. Okay, I've copied. So the command I'm going to configure the NAT pool. I'll use the command IP NAT pool. I will name the pool as pool 1. Then I will specify the first address, that is 209.165.76.196. I will specify the last address. The last address should be 199 because we are told there are 4 addresses in the address space. I will specify the net max. The net max is the next net max, I say 255.255.255.0. I'm done configuring the IP address pool. So in this pool there are 4 addresses. Oh, sorry, the net max is wrong. The net max is supposed to end with 252 according to the net max that is given. I'm done. Okay, now I'm going to configure the dynamic NAT itself using IP NAT command. So I'll say IP NAT inside source, I say list. This is the command IP NAT inside source list. I will specify first of all the access control list that I used to identify the private IP addresses to be NATed. So the access control list was named ACL1, so I say ACL1. Now I'm going to specify the name of the address pool. In this case is pool 1. No, first of all I say pool, then I specify the pool name, that is pool 1. I'm done. So the configuration of NAT is done. I can save the config using the command copy run start. I'm done with the configuration. We are going to test again communication from PC1 to the server and see if it will go through. So I go to PC1, I will do the same ping again to the server to see if it will go through. Let's see. Ping goes through, meaning that PC1 is able to communicate with the server. Okay, in order to confirm this, we are going to check on the router to see if there's any NAT translation that has taken place using the command show IP NAT translations. As you can see, PC1 has sent 4 ICMP packets, and for each of the packet the public IP address that was used for the translation is 209.165.179. that is part of this IP address pool that we specified or that we used to configure the NAT. Then the source IP address, the private IP address was 172.16.10.1. So the router received ICMP packet from 172.16.10.1. The destination was 209.165.201.5. that is the IP address of the server, and the router replaced the source IP address using 209.165.76.179 as the public IP address. Thank you for watching and see you in my next